The science is pretty clear and getting clearer by the day. Water cools the planet. Repeat after me. Water cools the planet. The more living, healthy vegetation we have on this planet, predominantly perennials and thus trees, agroforestry systems and healthy forests, the cooler the climate is and the less extreme weather events occur. Living planets literally make the Earth sweat and remove heat from the biosphere. Humans have systematically devegetated the Earth, as Judith D, Schwartz, friends of the show, likes to say, and the climate weirding is suggesting we might have gone too far. Now we're getting real calculations. How many square kilometers do we need to regenerate to lower the global temperature by 1 degree? If this is all starting to get clearer and clearer by the day, why isn't this more common knowledge in the headquarters of banks, insurance companies, sovereign wealth funds, governments, etc.? Today, a story of a successful entrepreneur getting sucked into the water cycle restoration, cooling the planet, and all of that good stuff. We share notes on why this movement, maybe the defining story of our time, hasn't really broken through yet, and what to do about it. Enjoy. This is the Investing in Regenerative Agriculture and Food podcast, where we learn more on how to put money to work to regenerate soil, people, local communities, and ecosystems, while making an appropriate and fair return. Welcome to another episode, today with the project lead of Cooling the Climate and the co-author of the book under the same name, Cooling the Climate, How to Revive the Biosphere and Cool the Earth Within 20 Years. Welcome, Rob.
Thank you for having me, Koen. It's a pleasure and delight.
I'm always excited for interviews, but when it touches on water cycle restoration, when it touches on cooling the climate, somehow there's some extra excitement. So I'm sure we can bring that today. There's so much to cover in your journey and where we are now in terms of regeneration and really bring it to scale or bring it home, depending on your point of view. But to start with a personal question, we always love to ask, how come you spend most of your waking hours? And this can be a long answer, don't worry, we have time, we have space. But how come you spend most of your waking hours thinking about how to cool the planet, let's say, with living beings?
Yeah, thank you. Well, actually, the journey started way back, so that we are in a systemic crisis as humanity because of the limitations of our planet was clear to me at the age of 16, approaching 70 now. And fast forward, I was aware of climate change since 1988 or 89 when James Hansen talked to the Senate in the US. And then actually I started to do some entrepreneurial work. I had companies, and so I didn't focus at all on this systemic crisis that was growing and growing, but not very visible to most people. But then when I came out of it, I sold the company. I had an exit in 2007. And I basically looked out.
Good timing.
Yeah, very good timing, yes. And I looked out of the window and I remember saying, my God, they haven't done fucking nothing. And the crisis was rolling on. And so what happened then is I wrote a book in 3 weeks after my friends kicked me, say, you said you're going to write something about it, but it was so depressing because basically it was a book showing that this would lead into global collapse with billions of people dying in the process, and which was obviously not very nice thought, and also it wasn't the solution. So part of the money that I made with the exit, I gave a lot away. And by the way, I spent a lot for 2 years having a life as a playboy, which was nice for 2 years, not longer than that. And then I also bought a small valley in the Atlantic rainforest in Bahia, Brazil, which I wanted to reforest and rewild, offset my ridiculously large footprint, because I've been traveling the globe like there's no tomorrow. And in that process, so I was amazed actually how fast that valley, which was largely pasture, how fast it regenerated all kinds of things. First of all, the trees grew very fast. It's the tropics. And when I started, there were a handful of springs that only gave water during the wet season but dried out. But planting some trees around it basically brought many of them back within 5 years and became perennial, which was amazing. So I was doing something.
Was it your first sort of experience with like regeneration and the speed?
Yes, before I'd been basically a city boy, and now I suddenly lived in a degraded tropical rainforest.
Because you moved there as well. permanently.
I built a house there, and most of the time I was there, and I was connected to the outside world with internet, and that's where I did my climate discussions. But meanwhile, we were trying to do something on site. And so the second thing that was really amazing was the influx of bird life. We were a refugee camp for birds because in the area around it there was a lot of pesticides, fertilizers, also hunting. In Brazil, they hunt everything that you find in the woods, and so somehow the bird life basically exploded, which also, by the way, brought down a tick plague under control. There was a big tick plague because we took the most of the cows out, and we left the ticks there, but they were at least taken care of by the influx of birds. And maybe the nicest thing, although I was too lazy to measure temperature and transportation stuff like that, was that people who helped me, day workers who lived in the surroundings, commented several times that it was always cooler in the valley than in their place, which was maybe just a mile down the road. Which I started to realize that we actually were starting to cool the climate locally, simply by having more trees. And then I started to dive into the theoretics of it. I had been familiar with the Gaia theory of Lovelock since the 80s, so that was part of my thinking for a long while. But then I came across the stories about the biotic pump and the evapotranspiration that takes care of cooling. People always think that trees mainly cool because there's shadow under them, but that's just one part of the whole thing. Most of the cooling is actually taking place on a sunny day because of the water that is evapotranspired through the leaves, and that takes heat from the forest floor straight into the atmosphere, where it, together with bioaerosols, another marvelous thing that forests produce, forms the condensation nuclei for raindrops to be made, and so you get clouds and rain and actually wind, all produced by forests. And once you start to understand that, then you really realize that's a huge missing piece in the climate models. It's very good in predicting the warming effects of greenhouse gases. It completely sucks at looking at the cooling capacity of the biosphere, specifically rainforests, but also actually ocean biology. So I got in touch with Peter Barnyard. He was an old hand. Peter is 85, I think, and he didn't work with Lovelock, but Lovelock was his neighbor, and there were a lot of discussions at his kitchen table with Lynn Margulis and Lovelock and others about the Gaia theory. So he was really one of the best people who knew this. And so we started to talk, and I visited him a couple of times in Cornwall. And the first thing that we did was to say, okay, we know that it cools, but nobody's interested in those qualitative stories. We have to quantify it. And so we went on, we wrote an article, I think in 2022 or so, and which was basically about how big the cooling capacity of the Amazon rainforest is when it's functioning well. And the outcome was also for us completely amazing. The total cooling capacity of the Amazon rainforest, if it's not in a year of drought, is roughly equal to the total Earth energy imbalance. So on the negative side, if you have a balance sheet of cooling and warming two sides, then actually the cooling capacity of especially tropical rainforest is gigantic, which made us, basically that gave us clearer proof, or evidence I should say, that a lot of the heating up of the planet, which has been attributed to the greenhouse gases, is actually caused by the destruction of the cooling capacity, the air conditioner. So then you start to think, okay, then how do we get temperatures back down by increasing the cooling capacity? And we did the calculations, and we came to a rough calculation about 2.5 million square kilometers in the tropical zone. If you would bring back forests, or you would bring back agroforestry where there's open fields, the additional cooling capacity through evapotranspiration, cloud forming, rain, etc., the net effect would be 1 degree centigrade of cooling.
Wow.
In other words, we can cool the planet, we can cool the climate.
And just to put it in perspective, I think what's often missed here is this is not just, as you said, the shade and the cool. This is not just local climate. You're cooling, especially at scale, you're taking heat out of the system, literally.
That's,
Just to repeat that fact, like how does that work? It's not that it's, oh, nice, because now we're in the shadow, in the shade under a tree, so we're a bit fresher because we're under it. No, this has an effect way beyond those square kilometers. How does that work? We've talked about it, but I've learned that we shouldn't underestimate how many times we have to repeat some of these things. How does that actually cool and not just temporarily move or create some shade or like temporarily fix things, but this actually has a much longer effect and is effectively cooling?
yes, I can explain it. A part of it is a bit technical, but I'll try to leave out as much of the technicalities as possible. But anyway, as soon as they get hit by sun rays, they start to photosynthesize. And for every molecule of sugar that is produced in that process, which we all know, it's oxygen, it creates oxygen, it takes off CO2, it makes sugars, which is the reason why we are able to live.
Are alive.
But the one part that is forgotten, that for every molecule of sugar made, there's a couple of hundreds of molecules of water that is evapotranspired. It is different per biome. The tropical rainforests have evolved over the last 100 million years or so to do this exceptionally well because there's most heat is coming in. So they cool more than forests in more moderate places, and they certainly cool more than the boreal forests through the evapotranspiration. And that process actually started about 100 million years ago with the angiosperm revolution, when we got flowering trees for the first time. And that actually, the flowering trees, they quadrupled their possibilities to evapotranspire, so to do that cooling. But the second thing that happens is because together with bioaerosols, this evapotranspired, this vapor, water vapor goes up in the sky, it then condenses because of the bioaerosols. And at that moment, several processes start at the same time. First of all, you get clouds, which are a nice white umbrella reflecting sunlight.
They reflect some.
So that's albedo, right. It cools. Then the second thing is because of the implosion of vapor into liquid water at cloud level, you get an underpressure. It shrinks by a factor of 1,000, which actually pulls up air. And because then you get a vacuum lower, that pulls air from the side. So especially coastal rainforests are then able to pull in moist air from over the oceans. Now, so at that moment, you create wind in a certain direction. And in the Amazon rainforest, which I've studied mostly, that process of evapotranspiration, condensation, cloud forming, and then raining out and making wind actually transports that water deeper inland. So the angiosperm revolution made it possible to hydrate the continents. Before, probably the forests were more on the edges. Now this mechanism made it possible to cool, hydrate Eurasia, the Americas, Africa, and so on. So there's another thing, and this makes the heating story very important. At the moment of this condensation, the heat that was in the molecules, in the water vapor molecules, because the electrons go to a lower stage, actually radiates out. That radiation is for a large part in what is called an atmospheric window, a frequency, infrared frequency out of where radiation that goes in that frequency does not get affected by greenhouse gases. So at least half radiates out immediately, just instantly.
Out into space. Out of our...
The other half, like a light bulb, it goes in all directions. So a part also goes down, so that needs to be recycled again. It also heats up the tropopause, the area where the clouds are, because of the updraft. Some of the radiation is outside the spectrum. It heats up locally, but the heat stays up there. And then slowly, while it's whisked away by, let's say, the jet streams over a period of time, it basically dissipates out into space. So it's a huge cooling mechanism. So we have a two-phase air conditioning system. One, evapotranspiration from a tree to cloud level, two, from cloud level out into space. And that's not recognized. It's recognized to a certain point, but not not by a mile good enough in the climate models. And this is simply a cooling mechanism.
Why is that? What do you? Because I remember talking and reading actually a really good intro into this, written by Rob Lewis on not Walter Jenner, sorry, about Mian, Dr. Mian, the late Dr. Mian, and where at some point these were considered as well to be part of the climate science, part of the focus, and then somehow everything became emissions. And I'm not saying there's a giant conspiracy theory, but we definitely miss one of the legs of the stool, as he called it so nicely. Like, you need to talk about vegetation and you need to talk about cooling. Do you have why has this been ignored? I think there the case was mostly like, it's much easier to measure emissions, and this is water vapor is just way more complex. But what is your version?
Well, you've already said it. The point is you can't model water. Water is, first of all, it is 3, or if you like, some people think 4 states. Ice, let's keep it to 3. Ice, liquid, or vapor. And it moves around all the time. CO2 basically, there's a slight local variations, but in the end, it's the same everywhere. You just need one point on a mountain in Hawaii to measure what the global situation is.
Parts per million. Yeah.
And climatologists think decades ahead. The definition was always the changes over 30 years or longer. Actually, the water cooling is happening on a daily basis, especially if you look in a rainforest, that in the morning, okay, so the sun hits the forest, and then within hours you see the cloud forming happening. If it's a perfect system, then you could say almost put your clock at it. That's like in 3:15 in the afternoon, the clouds have now gone so high they rain out with the refreshing rain. That then opens the skies up so that the sensible heat that's left in the evening can radiate out. It's perfect, but it's a day cycle, and climatologists have no idea what to do with day cycles. They want longer stuff. The second thing, and that's a rumor, I think I got it from Walter Jenner, but I'm not sure. So that was that under Carter, there were the first real discussions about climate change in the White House. And so the climatologists say, well, yeah, basically there's 2 problems. We got greenhouse gases on one hand, and we got water on the other hand. Well, greenhouse gases we can easily measure, and but water, it's impossible to measure and to model, and because it shifts shapes all the time and it's different in all places. So then Carter says, well, then, so give me the parameters on CO2.
And with one word, the whole climate scientist world went into one direction.
Exactly, got blind, operated with one blind eye. Maybe it's a rumor, I can't verify this one, but it's a nice story and certainly important if it's true.
And do you have the feeling, of course we are in a bubble, and also maybe a water vapor bubble, but and I've seen, at least in my relatively short tenure in, let's say, the regeneration space of the last 15 years, let's say this topic of regeneration at scale, where we talk about not just at a farm level, not just even at a valley level or a watershed, we start talking about much bigger, and what kind of influences it has beyond the farm gate, let's say. That kind of small water cycle, and of course with Walter Jenner and with many others, has starting to take off a bit. It's still very early, but in your experience over the last decades, have you seen, like, what would you, if we take stock now in 2025, it's the summer in the Northern Hemisphere, obviously not in the South. What would you say currently, when you just published a book on cooling the planet, what would you say, how are we in terms of neglectedness and in terms of response to this and in terms of carbon funnel, which the funny picture we see constantly?
Yeah, so...
Very long question.
No, I understand what you say, and I really don't know. I can tell you that there's now thousands of us fighting with the early people like Peter Bonyard and Walter Jenner, etc., Mian, to trying to get this into people's minds, and it hasn't gone very far yet. There's one good thing actually. As in 2023 and 2024, we had sudden spikes in global temperatures. And basically, that's way outside the scope of the IPCC models. They don't want to really admit it, but they're completely off. It's completely off the charts.
Which means their models are flawed, or at least cannot capture this.
Exactly.
This, yeah.
And of course, it's very scary if you suddenly get an acceleration of heating up and extreme weather. So I think in that sense, the traditional climate scientists are getting desperate and are looking for solutions. Well, here we are. We've been waiting.
Those two things are not necessarily connected. They might get desperate, and we all get desperate, but doesn't mean we start looking for solutions. If they're good scientists, of course, they start questioning their own hypothesis and start looking beyond. But I also can imagine it's just too scary, or you get into all the doom scenarios and all the doom and gloom and shut off for any potential other ways forward. Or do you see an influx, or do you see in your correspondence with people that more people start to show up with these and knock on your door with these kind of questions?
Well, I've talked to Sir David King, who's a major climate scientist from the UK, and he is moving in that direction for sure. Has already acknowledged that the revival of ocean biology is crucial for carbon sequestration. But he's moving in that direction. Professor Carlos Nobre, who was an vice IPCC chair, and he leads the science panel on the Amazon. We were with him 2 weeks ago in Exeter on the global tipping.
His brother is Antonio Nobre, right?
Yeah. They have.
Yeah, we had Antonio on for a lovely 2 hours. I'll put the link in the show notes. Anyway, sorry.
Antonio was very much advocating to get the biotic pump into the climate models. And Carlos, who is basically the heavyweight in terms of local acknowledgement, was very reluctant to do so. But 2 weeks ago, so we were at the Climate Tipping Point conference in Exeter, and Peter was actually in a workshop with Carlos, and Carlos actually said that the biotic pump is absolutely important in the fight to avert the tipping point of the Amazon rainforest.
The Amazon.
So slowly we're getting there, but I think, and it's something I would love people to look into. So Peter and I, we calculated the cooling capacity of the rainforest, and there was something very funny. I had at another conference, the International, for Earth Simulation in Geneva in October. I was getting in a discussion with another vice IPCC chair, Judith D, and I basically said, in the kindest possible words that a Dutch person can say,
"Ooh, this is getting interesting."
Their model sucked. But anyway, and then suddenly it dawned on me, we are always saying that you can see the signature of a large drought in the Amazon in global temperatures, because then the biotic pump doesn't work, the heat exchange stops to a large extent. So we should be able to quantify that.
So the release valve of temperature is then stops for a bit.
Exactly.
And which kicks all of us globally into a crazy year, basically.
Exactly. And so while I had the discussion, I suddenly realized there was a 2005 drought in the Amazon, which was an ENSO neutral year. So no El Nino, no La Nina. So that usually makes things more pear-shaped to understand. Anyway, so I actually called, during that discussion with Sukla, I called Peter. I said, Peter, in 2005, there was this drought, which was a short-lived drought, but we can actually calculate how much that would have added to global temperatures. Can you calculate it for me? 15 minutes made.
Please.
Exactly.
Now, please,
15 minutes later, he called me back. He said, it's 0.244 degrees centigrade, which of course is an absurd exact number. But anyway, we had this ballpark, and we looked into the climate records, and it's a funny tip in the spike of about 0.2, 0.25 in those few months, and then it withered away and nobody ever noticed that bloody thing. So for us, that's evidence, and actually we're still waiting for the right precipitation figures for 2023 and 2024, but we think that a large part of the spike of the temperatures in those 2 years are related to the droughts, the absolute record droughts in the Amazon, and by the way, also in the Congo, because the Congo droughts are connected to the Amazon droughts. So we're waiting for that, but once we can quantify that and say, okay, it cools this much, then maybe the world will at least try and check our calculations, see if we're saying something sensible.
And these calculations and these models and scenarios, and I think we'll get to the future piece as well, like where strategically, as you say, where to restore and regenerate. In terms of technology, and investors always like to ask, why now? Like, has this been possible before, or why Is it relatively easy? I'm not saying anything is easy. I'm doing air quotes for people listening to do those now, and that Peter can do that in 15 minutes. Like, what has that shifted now with the explosion of machine learning, simply rough power of computers compared to 10, 15, 20 years ago, or even 2 years ago?
Yes, actually, so once you come to that conclusion, you start to think, okay, how? I'm not interested actually in all this science. I want action. And so if I just told you that, so if we could do the regeneration of 2.5 million square kilometers, about 40% would be in the Amazon Cerrado area of South America. Then how do you do that? And
Just for people to have a sense, how big is 2.5 million
it's the
square
size of
kilometers?
Argentina. It's
Not not small, but not impossible or not of
it's
this world.
substantial. At the same time, I think, okay, so since we started to measure climate change, which is what, 1880 or so, we have actually taken away an area the size of China, which is 4 times Argentina from the Earth. So it's also not impossible to put it back. Anyway,
And back in this case means, sorry, then we get back to like revegetate, having a live vegetation, forest, agroforestry. Like, as I think Judith D. Schwartz likes to say, like, we devegetated the earth quite
yeah,
significantly, and we need more life,
that's it.
basically, in all forms and all shapes and more complex.
Yeah, yes, but we have to do it strategically. We don't have infinite time, so
Nor money. Yeah.
or no money. No, nobody is interested in so far in these. But maybe that will flip pretty soon too. But no, but because the Amazon is the only tipping point. We all know the climate tipping points, right? There's what, a dozen of them or so, and this is the only one where we can actively, directly intervene by putting vegetation back, protecting and putting vegetation back, and transitioning from open fields to agroforestry. So, okay, now coming back to your question, why now? First of all, I think the science of the biology actually making the climate. If I talk from a Lovelockian perspective, I would even say the biosphere makes the atmosphere and the weather and the climate. And once you start looking from that living perspective, then suddenly your solutions become clear. So it's from a scientific point of view, which we also, and then we realize that there's actually the bacteria in fertile soil that actually help us to create the metabolisms for life to thrive. So, and we are destroying that systematically. So I think so. The science is there. Then the satellite measurements are making it more and more easy to very granularly see on what is happening everywhere, because a lot of this stuff happens in places that the centers of power are completely uninterested in, which is rural areas, and especially rural areas in the global south, the most neglected area of the world. But actually, maybe they are going to be the heroes of the game. Then so then we have the technology, the computing power, which of course increases, and AI is a little early to say, but you can see that the modeling with AI of regenerative landscapes is already starting to happen. And that changes almost by the day, I would say. So all these elements together make it now possible, and that's what I'm building. And I'm going to use this interview also to do some promotion here, because the idea is that, okay, for the Amazon, the basic idea is pay everybody in the forest to protect and regenerate the forest, and change open fields to agroforestry and connect that to markets. That's an easy idea, and it's extremely difficult to implement, but we're getting there. The idea is that you have a digital financial platform where you can upload your land, be it an indigenous community or an individual farmer, doesn't really matter. Then we can run that through the systems. And okay, first there's a baseline. So the satellites tell us what's there on the ground in terms of humidity, on temperature, carbon, whatever. And then it runs a regenerative landscape design on that piece of land, which gives you a draft outcome of why don't we make it like this, but that focuses not just on the ecological values, because people have to make a living, so especially also on the economic values. And you see quite often that well taken care of agroforestry, after a few years, triples, quintuples the cash flow out of a certain area. And we can see that. We can module that on sketch,
Yeah.
on screen. So, and then you get your monitoring, reporting, and verification process, which was always, it's a hell to do carbon credit projects, but basically you can also automate the whole bloody thing. So you can just get real-time updates of what the situation is, and you can model how much carbon would come out of that area, let's say in 20 years. So let's say we have a smallholder farmer, and that area can produce also 1,000 carbon credits. Then the system gives a carbon credit mortgage, which is a loan with the underpinned by the carbon credits that are going to be produced. We calculate the transition finance that's necessary to get, let's say, from doing corn or
Current state
to an
future,
agroforestry system. Okay, let's say that costs $10,000. The value of the $1,000 of carbon credit is $30,000. So you get a loan for $10,000, which is your mortgaged and is underpinned by the carbon credits. And as long as the trees grow, you don't have to pay off your loan. In fact, at some point in time, you might even get additional money from the carbon credits as well. But if you cut them, then you still have the loan and you have to pay it back. So that's the carrot and stick. And then later on, and I think that is the big hedge, once the world wakes up to the cooling capacity of forests, not through the carbon cycle, but through the water cycle, these things will go up in value by magnitude. And then greed will help green to invest in bonds that, or whatever financial instruments that put money into regenerative agriculture and the protection and regeneration of forests. That's the Arara platform that we're going to build. We hope a first model ready at COP30. And the idea is then that there's about 10 million people, including kids and everything, really living in the forest, in the Amazon rainforest. Most live in cities and larger towns. So if you would be able to pay those people on a regular basis and monitor what they're doing, and then we think that the total net effect would be the regeneration of the Amazon rainforest, including all the now disturbed atmospheric hydrocycle. And we got ourselves the first tipping point that we have moved back from the brink.
And how, like, you make such a crucial point on when the world wakes up to the cooling or water cooling, the fact that water cools, how do we get, that's always the angle with, and of course you're an example of that, but how do we get more entrepreneurs or more people that, not just the science part, as you said, I don't care too much about the science, I care about action. What I think I've seen happen a lot in the region, let's say agriculture space, is that entrepreneurial people are moving into the space. Somehow they get bitten by the soil bug. Is it through health or inequality or carbon or biodiversity? Doesn't really matter. They get somehow hooked to regenerative agriculture and food. And I'm wondering, like, how do we do the same with water cycles and water cooling? Like, how do we make sure that the most entrepreneurial people with experience elsewhere, maybe with a bit of resources, but mostly that are able to do things and not that the world needs to be run by entrepreneurs, but creating something from scratch, which could be a nonprofit, is very rare. Like, not many people are able to do that, and managing teams and raising funding and all of that. Like, what do you, as one that has made that jump into, let's say, water cycle restoration, what do we need to do to get more? Like, how do we get more entrepreneurial peoples into this space?
Well, I just applied to be a volunteer on the Planetary Solvency Task Force. What we, of course, have to do in the policy space is to, as I said, to get the externalities on the balance sheet. That's always thought of as a negative sense. Oh, you're polluting, so you have to get a negative thing on your balance sheet. Actually, if you're cooling and if you're doing something about biodiversity and you protect food and water resilience, then actually that should be measured on your balance sheet as well, which actually would increase the value of the companies that invest in those systems. So the policy makers, of course, have to do this. And honestly, this is it's a bit difficult to tell the story and get them to move in this area. But we're moving there. I think in that sense, the EU is, although it's bureaucratic as hell, it is moving in that space. And for instance, now the call to develop nature credits, for instance, could come into that space. So Yeah, we still have to push and push, but what we want to do is actually prove that the system works at smaller scale and then scale up. And that's what we're going to.
And yeah, what's the smallest possible scale? Like we sometimes talk about a watershed. I think Ian talked like, of course, around the Mediterranean in Spain, where Ian was based. Like, what's the smallest, depending on the context? I know this is not a straight to answer, but what, because once, I mean, it might be a few years down the line, but once we show that this is, we've done the Lost Plateau and some other place, once we see like how relatively quickly, as you saw, land can come back and actually we start influencing rain patterns and things like that. You would imagine if we document it well and we share it on Instagram and all the social media, then there would be a trigger. But how small do we need to get? Like, what's the MVP in this sense?
Yeah, I understand. Well, let me first say that the bigger the better, and it's not a linear thing. It's actually an exponential thing. So in that sense, the small ones really do very little. And at some point, actually, you had been Shahid on the interview. I haven't
Shout
seen
out
it yet,
to Ali.
by the way. He's on the way back to. He was with us in the UK last week. But so we see that at certain levels, the cooling, which is already very local, a city park actually cools, and that can be measured. And it measures, it's not just in the park, actually, the cooling actually extends to a couple of hundreds of meters outside the park. That has all been established, all the papers are there. But then if it has a certain volume, and we think, depending on the situation, let's say about 100 square kilometers, then we get the first biotic pump kind of circulation, improving the weather systems. So, and then if you go larger scale.
That sounds very doable. Yeah, just to be.
Yes, and especially.
Around cities.
Yes, yeah, especially if you do it in what we call acupuncture points. There are trade winds which are actually not caused by the biology of the planet, but they really come into certain points. And if you put a forest there, that reinforces the already existing trade winds, and you get your bioaerosols and your evapotranspiration, then we can for sure already create precipitation downwind. So it would be very doable for places for the Arabian Peninsula, etc. So that now back to your question, how small? I would say really very small, an acre, 2 acres is already in that sense okay, because the regional cooling, the cooling in the area itself, is great. It also produces soils under there that are becoming alive. It will increase agroforestry. Let's say if you have acai with coffee and shade trees or something. So it will increase the economy of that area. So even at the small scale, there are already multiple benefits also economically. But you have to bring it to scale in order to get the real benefits. And that's the whole idea. If you have a platform like that, let's say, call it the digital twin of the Earth, that now has a layer where you can bring your land in, model it, and make money by transitioning it into a phase that supports the world's climate, then, yeah, it could accelerate. So, I don't know. I'm not there yet.
No, and this is a story we'll keep, and a narrative and a story we'll keep following. And what have you seen from within that movement? You say we're a few thousand now. My sense is like to bring this to scale, we'll need finance. And not because I think finance is the answer to everything, but it's a very powerful tool. And simply the amount of money that's available in terms of grant funding compared to investments, it's just completely dwarfs it. But there seems to be, and there's also definitely in the regen food and ag space, a certain aversion to finance with very good reasons, because let's say the extractive agriculture and food space has been using finance as a tool very diligently, let's say, for their goals. And not to do us and them, but they've been very good at that. And we haven't really. My part of my question was, like, how do we get more entrepreneurs in this space? Like, how do we start building that bridge to the finance world, to the insurance world, to the big pots of money that need another language and that need maybe other models or need other narratives, even just to be able to start engaging with this, with you coming from the entrepreneur world. Like, what have you seen in terms of readiness to talk with finance in the, let's say, water cycle restoration space?
Yeah, I understand. Well, actually, although if I knock on the door, they usually don't open, but I want to start really at the top of the financial pyramid. Why? Because all reinsurers, the sovereign wealth funds, the central banks, etc., they all have the obligation to throw all their models and their projects past the actuaries. The actuaries have already for 15 years saying your asset base is going to hell if you go on like this. At some point, they need to listen. And if we flip that narrative and say, okay, if you invest this much in cooling the climate by restoring the biosphere in a strategic way, then maybe your ROI on the bonds that are given out are not that high, 6 or 7%, but it's a hedge because it's also a protection of your assets. So I think if we can drive that message home at some point, I think it's possible. There was a recent report from the Norwegian Sovereign Fund, 1.6 trillion or so in asset management, and they came to the conclusion that more than 90% of their assets were vulnerable to the effects of climate change. So once that's understood, and you have that double edge, like, okay, a small ROI on regenerative investment and an improved protection of your asset base, I think the actuaries will say, you should do it. Bob's your uncle.
But have you seen people like from their scenario plannings of these kind of institutions starting to sniff around on your Substack or starting to reach out? Have you done, like, are we at that phase now where you and others and Ali Bin and others have been invited to give these kind of future forward looking presentations and discussions, if you can disclose them, not, but like, are we in that phase now, or is it still they should, but they actually haven't really knocked on the door yet?
There are people in all these financial systems that are looking at this. They can't convince their CEOs yet, and I don't think that's because the CEOs are quite often very smart people, but they need to...
Otherwise, they wouldn't be up there in many cases. They have to be very sensitive and very political and very smart.
Yeah, so there's no doubt there. But they have no room to look at the longer term. They have to look at the next quarter or max the next year. Otherwise, you know how the whole system works, that as soon as you do one thing wrong, then your share price goes down, etc. So they're caught in a system that is actually destroying the planet. I think that large funds like the Dutch ABP, for instance, or the Norwegian,
which is a large pension fund, just for
or the Norwegian wealth fund, they can set aside a relatively small for them amount of money, let's say 10 billion or so, and experiment, but it's large enough for them to make it investable and small enough for them to make it get it into a risk management class that they could use, and then apply it and see what happens. And I think I have a feeling like if we come to this conference, like the Tipping Point conference, we see people from Swiss Re walking around, from some major funds and banks. They are really aware. I think they're looking for a way how to do this. And I think technology will help, because if you have a technology platform that can really do all this reporting on all that activity real time and without tons of management money to do it, then I think it will become feasible. And we have to.
Yeah, and I think we have to. But also I think there's a piece there of, I think the weather makers called it in the Guardian article, like we lack imagination. Like we lack that it's even possible to restore to a degree that we influence climate. I think there's as soon as you see that, or if you have seen that, or you have your own piece of land, or you've been in certain places where just to see the speed and the larger effect, and then of course you go into the science and this is a release valve for a lot of heat. And actually this is not just local cooling, but it has an effect globally, etc., etc. But to be able, it's almost like, and you mentioned it somewhere as well, like reimagining our role in this climate discussion or in managing the planet. Like we are a keystone species.
Exactly.
And we've been mostly on the negative side. And are we ready? We've had quite a few conversations on the podcast on that. Are we ready to take the positive one? But it comes with a lot of responsibility.
Yes. Well, it's obvious that we have to take responsibility as co-stewards of this planet, because otherwise, basically, the planet will do it on its own without us. And she has time enough.
Yeah, we'll be like that annoying flea somewhere that just get hooked off your back. And okay, let's get back to regeneration and syntropy, because that's what I always do.
Exactly, yeah. And I must say, I quite often I get I'm people call me a megalomaniac, but I said, well, no, it's not really the point. I'd rather sit on the beach and drink caipirinhas than doing this stuff. But the point is, we have to approach this problem with something that is of the right size. That it really the solution has to be of the same size as the problem, so it has to be planetary by definition, and then of course you have to go from planetary back to the micro. I actually did some calculations. If we were able to, let's say tomorrow, get the 500 million smallholder farmer families around the world and indigenous folks and stuff, and give them finance to regenerate their own area, we would be there, and it's not even that expensive. Certainly not for saving the future from climate catastrophe. We can't reverse everything that's going on, but we can do a hell of a lot to get, for instance, to bend temperatures down and to mitigate extreme weather events, as Mian has shown, as the weather makers have shown, as Walter Jene is very clearly telling. There's loads of people who are telling the story in a different way, but it's about the same thing.
And to ask a question we always like to ask, and let's say we do this in a theater, in some financial heart, maybe at the Norwegian Sovereign Wealth Fund or somewhere, and the room is full of quote-unquote financial types. After an evening full of inspiration and imagery and maybe modeling as well, I think that's actually an underestimated piece of being able to imagine this. Like if we can start modeling and showing and turning it into like this is what parts of the Amazon could look like, or this is what part of the Mediterranean could look like. We're now used to this, and actually temperature could be this, and this the vegetation, and put on your Apple glasses or whatever and see it, and maybe even hear. That would be very interesting, let's say, even to trigger our imagination, which I think in many places we've lost to a certain extent. But anyway, getting back to maybe we all have them Apple glasses wearing in the audience, the finance types. But the next day they're back at their desk, they open their laptop or they're on their computer, they see their Bloomberg terminal and all of those things. What do you want them to remember? What is one seed or nuclei that you want to plant in their mind that they remember from the evening before and that hopefully they take action on?
Yeah, it's a very good question. So, when you have your own house and at some point you think, well, it really needs an upgrade. And you go to the bank and you ask for 100,000 euros to put in a new bathroom or whatever, solar panels, the works, nicer garden. And the bank says, well, it's okay because the asset has enough value, so here's your 100,000, make sure you pay it back on time and we're making a nice buck. Now, if you apply that to the planet, you want to make the nicest possible planet make a makeover that makes it absolutely habitable for our kids and grandkids. And it's going to be a lot of fun, actually, because remodeling your house is always a lot of fun. You have to do so. So
until you get the contractors in.
Yeah. That's true. There is some detail that will bug us for sure. No, but if we can get into the mode that we can actually fix this problem, and that the outcome, if we do it right, can become a much more beautiful planet, a much more livable planet, a much more equitable planet, where we also don't start to bash each other's heads in instead, but actually are nice to each other. And because there's a lot less stress, because the planet is basically taking care of us again and providing simple abundance as it has always done, then maybe there's a way out of the mess we're in.
And what could be an unintended consequence of, like, just to play devil's advocate here, like we revegetate large swathes of, like, maybe there's none, but what could be unintended? Malaria comes back everywhere. And I don't know, like what's the negative if we would go in that direction? The unknown.
Yeah, the unknown
stuff goes
unknowns.
wrong. Yeah.
Well, the unknowns.
The unknown
we don't know,
in case,
by definition.
I know, but in case it's negative, what bugs you sometimes at night? Not like if this would happen overnight.
It doesn't bother me at all, because the direction we're going in right now is, for me, it's completely clear that it will end with a much, much smaller amount of humans, which in itself maybe is not such a bad thing at the end of the century. The only problem is the time in between, going from 8 to 4 or to 2 billion or whatever, is not going to be a fun time for the people who will live then. So I take the risk, and it's an iterative process. There's so much we still have to learn in the whole process. So you can't say, okay, here's the blueprint, and everybody look sharp and start building and tell me when it's over. No, of course not. The iterations will come. And there will be negative consequences, of course. But the total package of positive benefits, I mean, you're talking, if you take the Amazon rainforest, it provides moisture to a large part of South America, which is one of the largest food baskets in the world. It delivers more.
You would expect them to be really interested in restoring, like the large agri industry landholders that are completely dependent on the rain from the Amazon, relatively nearby, relative, again, air brackets, would be like that kind of connection between production, agriculture production, and rain producing would be an interesting bond, outcome-based payment scheme, something in that sense.
Oh, yes. And again, the CEOs of these large are very smart people. And Andre Lima, who I think he's number 2 or 3 in the climate ministry in Brasilia, he told me that he was at a closed-door session with 10 of the largest, of CEOs of the largest agri businesses in Brazil. And what he said was actually they all were completely aware that their harvests were dependent on the moisture coming from the Amazon, and that without the Amazon they wouldn't have it. The biggest problem was cultural, because they come from cultures in areas where you're not supposed to be a tree hugger. Yeah,
Definitely don't plant them.
exactly.
Yeah. But that's an interesting. That's almost like a cultural shift in terms of this is an investment, not a cost. This is making sure that we can harvest this soy for the next few decades. Otherwise, there won't be any soy. And that's, yeah, but we need a different narrative, or we need definitely not a tree hugger narrative. Yeah.
Absolutely. It has to be. It has to be a business case. That's why, by the way, although many of the projects in this space need some seed money as a startup from philanthropy, but I always tell everybody, make it for profit. Otherwise, you can never scale it.
You're for sure making friends with that. Yeah. How does that land with the space, like your business focus?
Well, I think more and more they realize that NGOs are very nice, the governments are very nice, but in the end, things can be done so much more effectively if you got a group of entrepreneurs and a great team working their ass off because they simply want to score a goal. It's much more fun. And so that entrepreneurial spirit, that spirit to win, I think is crucial to get this done. And so I focus more on the entrepreneurial space than, of course, philanthropy is necessary to kickstart it because almost nobody understands the story. But I would say there's hundreds of projects around that if you would give them, let's say, $1 million each, the effects would be amazing. And of course, 20% will die and will not work, but there were a couple of that will have amazing results on all levels.
That actually brings me to it's a perfect bridge to a 10x question in this case. So let's not do 100 million, but imagine you were in charge of $1 billion or €1 billion. I think in this case,
the difference is 15%.
Depends which currency is better.
Yeah. It's the ballpark.
Yeah, so pick your currency. What would you do? What would you focus on? Of course, we're not giving investment advice. I'm not interested in exact dollar amounts, but I'm interested in like priorities. Like what would be big buckets that you would focus on if overnight you suddenly had access to those kind of resources? That I'm not saying anybody should have that kind of concentrated resources, but let's say it happens. Somebody passes away, a big estate gets sold. I don't know, you didn't know you had this kind of money coming and suddenly tomorrow morning it's on your account. What would you do? Or you get a phone call of your banker. What would you do?
That last one is very unlikely. But, well, centrally, I would actually build out the Arara and deploy it. Why? Because that is the digital financial structure to scale up. Then you start to talk with people to actually leverage that money to get maybe $20 billion bond structures to put into that system and then upload land and do the refinancing of the transition of that land and show that it works. Of course, it needs to be proven, and if it works, then you scale it, and then if you just to give you an idea, it was very funny. I made a calculation on what it would need to protect and restore the Amazon rainforest, which, mind you, is something the size of Europe, and it was about $2 billion per month, which is a very small amount compared to the size of the problem. And then a couple of months later, so I had done all the calculations, and a couple of months later, somebody sent me an article that somebody else I had never heard of, and they never of me, had calculated how much it was needed per month to do that. It was $2 billion.
Do you enjoy those processes, that calculation? Is that like almost a hobby slash a strong interest to work on, okay, what will it cost and what scale do we need or what size, square kilometers, etc.?
I don't know if enjoying it is the word, but if we want to get ourselves out of the mess we're in, and it's an existential mess, then we have to fight to get it right. And I know that if you talk to business, you have to quantify. I've always said that it's amazing what classical climate science gets away with. For instance, they say, well, they come into a boardroom and they said, well, we figured out that climate sensitivity of CO2 is somewhere between 1.5 and 7. They get kicked out of the boardroom immediately and come back when you got real figures. And the same thing goes here. We need to quantify the effects, the benefits, the ROI, etc. Yeah, and so in that sense, I don't know if I really like it, but I'm running companies on the side, so I'm used to seeing these things. So it's not too difficult.
And beyond, okay, so we were still talking on the billion you could put to work. So you would build Aurora further. What else would you do? Would there be you would leverage to get 20 billion into the system? Are there other pockets you would look into? Are there other areas beyond the Amazon? Like, okay, these are these acupuncture points where actually I would love to prove X, Y, Z also in Pakistan or also in Australia. Like what would be, or would it be absorbed completely of what you're doing now?
No, I would use it as seed money for projects everywhere in the tropical rainforest zone to reverse the destruction there, because that is by far the largest leverage that you could have over the system. I would use a part of the money, and sorry, I didn't make a budget yet. I'll send you the spreadsheet later. But so
we're collecting these of all the 400 people we've interviewed just to get the hive mind to work.
Well, it's wonderful. So we know roughly what to do about reviving ocean biology. And that is, funny enough, in different places, completely different recipes. So in some places you have ocean deserts where you could do some optimization of plankton blooms that actually would then that would actually improve the vertical water column mixing, which would cool the oceans and actually would also bring clouds and rain. Not many people know that, but plankton blooms actually also create clouds and rain. So, but on the other hand, there's places where there's eutrophication, where we also know how to clean it up and get back biology. So I know enough people in our space who are desperate for money, who would get some funds to say, okay, go ahead now, show your bag of tricks. And then the other one, of course, is there is a huge problem with the Arctic. And so there needs to be, and funny enough, we still only have a vague idea why there is Arctic amplification and how could we reverse it, which actually has an immediate effect on the amok. So I would do some very specific research grants to some of the smartest one. By the way, I have one that I would like to that's from myself. Actually, it's not. It actually came from an idea from Brian von Hertzen. So
I was saying that ocean work reminded me of when we had Brian on.
Yeah, well, actually, I was talking to Brian one day, and actually, for some reason, I had a map of North America behind me. Or maybe I forgot. But anyway, so he said, by the way, do you realize that the moisture stream over North America starts especially pumping when in the spring over there, the leaves unfold, and so the evapotranspiration starts, and so you get your biotic pump. Now, of course, especially in the Midwest, there's been a lot of deforestation. But if you look at you have these videos online on YouTube, you see actually that when there's spring over North America, this moisture gets pulled in from the Caribbean, partly actually Amazon moisture, but also goes all the way up to the Arctic North and up to Greenland. So let's say, okay, magic wand again. You reforest.
You're taking my question, but what would you do with the magic wand? Yeah.
Well, you already gave it to me, but so if you would, let's say, you could reforest strategically in North America. That doesn't mean complete forest cover. You don't need it at all, and that would pull.
Which is an important point, actually, just to make. Like, that doesn't mean we need an Amazon version of a temperate rainforest all over North America to have this
Absolutely
to work.
not. Absolutely not. But there's patterns actually. So you need. So the biotic pump works in waves, if you like. So it needs to
Certain
land
pieces, like
jumps.
Jump.
Yeah.
What is that? What is the Olympic sport that always looks weird? Like that weird to jump. Anyway, you need to be at certain spots to be able to recharge, recycle,
exactly.
push. Yeah.
And then what would happen, actually, you could probably improve the moisture over the Canadian Arctic and Greenland, improving its albedo. And if it's enough, actually, you can heighten it, and so that would cool. It would be double cooling, which actually would slow down the slowdown of the AMOC, because you would have less melting on Greenland. So we'll have to research. Ali bin Shahid, which you had on your program, actually discovered that there is a whole group of people that are looking into the Arctic dams.
The hydropowers, I read the articles.
Yeah, so
very dense, but highly recommended for anybody interested in hydropower in the Arctic circles. Why that is great for energy perspective, but horrible from temperature.
Exactly.
Holy moly.
So coming back to your story, so okay, my billion, I think I need more than $1 billion. But anyway, but at least part of that billion would be to research fast action research projects to do something about the Arctic amplification and the connected AMOC slowdown. By the way, the AMOC is also slowed down by when the Amazon dries out, because it pulls less heat and moisture from the Atlantic. But now we're going too far. But anyway, so
just for people listening, AMOC is
what is the God, it's such a
wait, I got it. Atlantic meridional overturning circulation.
Yeah, it's a horrible word. So it's basically the sea, the circulation of large sea currents. So there would be, so apart from doing direct investment in on-land regenerative action in the tropical rain zone, that would be my priority. We could do ocean biology regeneration experiments, very different in kind. Everybody thinks it's because we're land animals, so we look at it as a surface of air, but it's as diverse as the landscape on land. So it needs all kinds of customized different treatments, no matter where you are. Then the Arctic needs to be investigated, and that's roughly my recipe for now. Did I run out of my $1 billion yet?
Probably, yes, but with the leverage and the 20 billion, you might get a lot further. And probably by the time you have been putting this to work, more have joined in, because I think like the crucial point you made before as well, when the world wakes up to the cooling effect of water, it's going to get a lot busier. And I think it's very similar into, let's say, the larger regen or the part of the regen food and ag discussion. I don't think it's a conversation necessarily about a lack of money, even though now I'm going to get emails from people saying we need money. But it's much more that most people are not looking at it at all, like how environmentally friendly, healthy, profitable food and agriculture could be, or land use, let's say, could be. Not saying it's easy, but the more people see that potential and see the possibility, like it's going to get very crowded in this space, which is a good thing. But we're going to have those questions. That's why I asked the $1 billion question, but we get those questions now. We get family offices that reach out and say, what do? I want to put a significant amount of money to work. And do you have the places to do it? Like what's the infrastructure, quote unquote? Where are projects that you can put 100, 200, 500 million to work? And we need to get ready for those kind of questions, because this money or these resources, this energy, because at the end it's just energy, will find a way to get in. And we probably need to be ready to absorb that, because that means a lot of trees in the ground. That means a lot of technology. It means we can do a lot more than we can now do with a very limited budget. Because if you look at the total amount, it's tiny. It's growing fast, but it's tiny compared to what we actually need. But we need to be ready to have those conversations, because if the Norwegian Sovereign Wealth Fund knocks on the door and says, okay, we have the 10 billion, as you said, like, do we know where to put it? And like, what are and are the people ready to have those kind of investor conversations compared to, let's say, the grant conversations we mostly had in this space?
Well, So let me first say that we do have, if you look at mapping systems like Restore, well, there's a lot of stuff that's not real, but Explorer.land, we work with Explorer.land of open forests. And it would be nice if you could put that link in. They have 1,500 projects. They're the nucleus of the Arara app and the system in the end. So they already have 1,500 projects which basically are ready to go or are at one already in there, but we could easily accelerate by financial things. And the Arara platform actually, it takes far too much time to have all these little projects in a whole onboarding process with people in it. Now they just go to a local Arara shop. There is a terminal, and they put a polygon in, and the whole process is managed digitally and is monitored digitally, and the payout is done digitally based on the effects, and the finance is done digitally and immediately upon you sign the smart contract. The money is in your app. So once you got it done, then you can go to scale, and it's monitorable, so then it's investable.
And that has shifted. Like this is possible now and wasn't necessarily, or maybe with a lot of tricks 5 or 10 years ago. But this kind of automation and this kind of, basically automation makes, like, I think Bart of Fresh Ventures likes to say, like, how do you cut large amount of money in small pieces?
Exactly.
It needs a lot of automation.
Yes. It's a sort of a microfinancing of 500 million smallholder farmers around the world that aggregately have all these amazing beneficial effects, even politically, because if we do it right, it would slow down, possibly reverse migration to cities in the global north, which is one of the largest problems that actually is eroding democracies in the global north, as we all know.
Yeah, if you want the countryside to vote differently, you might want to revive the countryside and get some more people there. And as a final question, we always like to ask, or sometimes it's the final, sometimes it's not. I have an idea of a few points where you're, let's say, slightly contrarian within your scene, but we like to ask in this way. What do you believe to be true about regenerative agriculture, in this case, say regeneration, that others don't? And this is definitely inspired by John Kempf. But like when you go to these conferences in Exeter, and when you go to, like, where are you different? What do you believe to be true that others don't?
Honestly, I'm a complete amateur at regenerative agriculture. I am approaching this from a climate strategy. I know how complex the setup of agroforestry is. It's also labor intensive. So one of the biggest problems actually to implement it everywhere is shortage of labor. And so I think we actually have to mechanize a lot of the agroforestry. I've seen already the first drones that cut acai from palm trees. So that's just an example, and I really don't know enough about it. So I think we need this micro technology for the scaling. That has to be part of that whole thing. The second thing is, I'm not sure if that is contrarian. What we have to find, and I don't know exactly how, but we have to find access to markets much faster, because if you're in an area and nobody ever grew coffee there, and now you start to grow coffee, you have no clue where you can sell it. And these processes take too long. So I have a feeling that we could do something with digitally there too. I remember I once designed very quickly a platform to do seed collection and dispersal over the Amazon, which would simply go by mail, but people have to get it in, get paid and stuff like that. And it wasn't that difficult. So it just needs to be built and deployed. But so I think technology would also play a role in getting agroforestry off the ground in its logistics.
No, absolutely. It needs to be more mechanized, and how exactly that looks like, we probably don't know, but there are many machines or tools that need to be built to prevent people necessarily to have to climb up trees, which is not only dangerous but also very time consuming. And does it mean we got to get drones with chainsaws on it? Probably to a certain extent, but these kind of complex systems need to be managed and need to be pruned at the right time, because we don't have the megafauna anymore that does that or did that for us. And so, yeah, we're going to see, I'm imagining with the current drone explosion and with AI and visual recognition as well, like what needs to happen in the system. How do you design a system with mechanization in mind? it's going to look very different, or it's going to be one of the keys to enable the scale up of these kind of systems. And that means a lot more trees in the ground, a lot more vegetation, which of course triggers a lot of other things we've discussed today. I want to be conscious of your time and wrap up. I want to thank you so much, first of all, for the work you do. You could be drinking interesting cocktails on the beach somewhere, but you're not. And you're talking here with us, and you're doing way more than that. And thank you for coming on here to talk about your journey. Definitely, and don't think the last time we talked, this is a severely neglected climate opportunity, severely neglected economic and environmental opportunity, and water cools, which is something we'll keep repeating on this podcast as many times as we can.
Thank you so much, Koen. It was a pleasure, delight talking to you. Thank you so much for giving me this opportunity.
Thank you for listening all the way to the end. For show notes and links discussed, check out our website, investinginregenerativeagriculture.com/posts. If you like this episode, why not share it with a friend? And get in touch with us on social media, our website, or via the Spotify app, and tell us what you liked most. And give us a rating on Apple Podcasts or Spotify or your podcast player. That really, really helps us. Thanks again, and see you next time.